Hi, let's get started on section 7.2 about properties of parallelograms. Our objectives: to use properties to find side lengths and angles, use parallelograms in the coordinate plane. Our essential question: what are the properties of parallelograms? All right, let's start by defining parallelograms as used from a previous course. The definition of a parallelogram is a quadrilateral, in other words, four-sided figure with both pairs of opposite sides parallel. So in parallelogram PQRS, by the way, this is the symbol used for parallelogram, we say that PQ is parallel to SR, PS is parallel to QR by the matching sets of arrows. So let's take a look at the theorems below that describe other properties of parallelograms. We start by saying if a quadrilateral is a parallelogram, then... All right, let's start with our theorems. If a quadrilateral is a parallelogram, then first property, opposite sides are parallel. We can mark with the matching arrows on opposite sides. Next property or theorem, if a quadrilateral is a parallelogram, then opposite angles are congruent. We have matching number of arc marks on the opposite angles, indicating congruence. And then the next property is opposite sides are congruent. And so we can have matching tick marks on opposite sides, indicating congruence. All right, so let's take a look at the three properties that we just wrote down in our notes to help us solve and find the indicated measure. So for number one, we want to find the length of AD. Let's take a look at our picture. We have matching tick marks on opposite sides. So that means that we have opposite sides congruent. Well, that would be how we set up our first equation. We see that we're given AB opposite of DC, and we know these two expressions, so we can set them equal to each other. For the other two sides, I want to know AD, which has no information, and then BC has an expression, but it's not enough to set up an equation. So I have to use these two first. And then just use your math algebra skills to finish solving the equation for x. So we subtract 4x from both sides, resulting in 3x equals 15. Then we divide 3 on both sides, resulting in x equals 5. Now what do we do with this 5? We're ultimately wanting to know the length or distance from A to D, so this length right here. Well, I know that this is equal to AD, so if I take this 5 and substitute it into this expression, then I can know the length of AD. So let's do that. And the result then is the length of AD is 11. All right, we're going to skip number 2 because it actually pertains to a property that's later in the notes. So we might have to come back and do this one a little bit later. All right, so let's use the same properties to see if we can find the values of x and y in this example 1. All right, so we can see all of our parallel arrow marks, and then we know the properties that opposite angles are congruent, and we know that opposite sides are congruent, so we can set up an equation based on these being equal to each other, so x plus 4 equals 12, then solve for x. And then we know that opposite angles are congruent, therefore y is 65 degrees. So in conclusion, we can say that in parallelogram ABCD, x equals 8 when we solve for x, and then y, which is equal to the 65 across from the congruent angle. And that's using the parallelogram opposites angles theorem. All right, I want you to try these two problems on your own, so pause the video, take some time to think through your properties, and try to find the indicated measures, and then unpause the video, check your answers. All right, how did you do? If you made some mistakes, see if you can figure them out. If not, bring your questions into class tomorrow. All right, early in the year, we talked about our consecutive interior angles. And it's a theorem that just simply states that when I have parallel lines cut by a transversal, the inside angles on the same side of the transversal are going to be supplementary. Those are called consecutive interior angles. We're going to use that information with these parallelograms. So our final two properties state that if a quadrilateral is a parallelogram, then diagonals bisect each other. So this diagonal bisecting this diagonal means that we have two congruent segments on each of the diagonals. And then consecutive angles are supplementary means that any consecutive angles are 180 degrees together. You can pick any two consecutive angles in the picture. So all the way around your shape, x plus y will equal 180 degrees. All right, we're given, let's do a proof here. Given PQRS is a parallelogram. Diagonals PR and QS intersect at point M. We want to prove that M bisects QS and PR. So we'll do a two-column proof, so let's get that started by setting up the two columns, statements on the left, reasons on the right. And your first statement's always what you're given. So write that out. PQRS is a parallelogram, reason, given. All right, so now let's think about the fact that this is a parallelogram. So by definition, if it's a parallelogram, then that means that opposite sides are parallel and opposite sides are congruent. So let's mark that. We've got opposite sides parallel, and we've got opposite sides congruent. Well, if that's true, let's put that in our proof. So that's what those statements separately can be in our proof. So let's start with opposite sides parallel. So we can say that PQ is parallel to RS is our statement, reason, definition of a parallelogram. Or you could say your implied statement, which is parallelogram implies opposite sides parallel. All right, the next piece that we can then conclude, because we have a parallelogram and we have the diagonals, which is also given, that means we could use the alternate interior angles theorem to indicate that we've got opposite alternate interior angles congruent. So that then allows us to say that angle QPR is congruent to angle SRP, and we can also say that PQS is congruent to, and I'm using different colors for my arc marks, but I can double and single just to also differentiate congruence. So for both of the diagonals, they can each serve as separate transversals to the parallel lines that we indicated earlier in our proof. And I mentioned earlier that opposite sides are congruent, so we can then next indicate that in our proof. We already thought about it, now we just need to write it in the proof. So our next statement can be that segment PQ is congruent to segment RS, and the reason is that parallelogram opposite sides theorem. In other words, parallelogram implies opposite sides congruent. Now we know from an earlier unit that we could prove triangles congruent if we have enough of the right combination of parts. Well, we just marked two sets of angles and one set of sides, and they happen to be in the order of angle, side, angle, which is a theorem we can use to prove triangles congruent. So that's going to be our next statement. Triangle PMQ is congruent to triangle RMS, and our reason is the angle, side, angle congruence theorem. In other words, angle, side, angle implies congruent triangles. And I've always said that once you prove triangles congruent, all the other remaining parts are also congruent. So include that in your proof. So any remaining parts are congruent. And because of the new congruence of the remaining parts, we can see that M indeed bisects QS and PR. And that's by the definition of the segment bisector. All right, let's take a look at example 2. We see that in this desk lamp, it's a parallelogram, the extending piece, which means that the angles formed here, this shape is a parallelogram, so we want to find the length of BCD and when ADC is 110 degrees? Well, we just talked about the property where consecutive angles are 180 degrees. So if we know that this angle is 110, so we subtract from 180 to get this one. So therefore it's 70 degrees. So that's using the parallelogram consecutive angles theorem. In other words, if it's a quadrilateral, then consecutive angles are supplementary. All right, let's take a look at another proof. So we have ABCD and GDEF parallelograms prove that angle B is congruent to angle F. So again, we're going to do 2 columns, so go ahead and get it set up. You've got your statements on the left, reasons on the right, T-chart. Number 1 is always your given statement, so write it out completely as is, and then the reason is the word given. So since both of these images are parallelograms, we can use the properties of parallelograms, which means that opposite angles are congruent, and ultimately we're trying to prove that B is congruent to F. So if we can say that CDA is congruent to angle B, and then we can say that EDG is congruent to F, by the vertical angles theorem, we can say that angle CDA is congruent to EDG. So I went ahead and marked the 2 pictures based on statements 2 and 3 with different colored arc marks. And what we want to realize is that since we just said that this angle is equal to this angle, so red equals the blue by the vertical angles theorem, then what can we conclude about angle B and angle F? That they are also congruent to each other. And that's our final conclusion statement, angle B congruent to angle F, which is what we were trying to prove. And we can say this is true because of the reason, the transitive property of congruence. All right, our last 2 examples have to do with parallelograms in the coordinate plane, so you will need some grid paper. And you're welcome to use this space on the opposite side of your journal to kind of help you with the rest of this information. All right, so find the coordinates of the intersection of the diagonals of parallelogram LMNO with the vertices at these locations. So take a minute to plot and graph out this figure. All right, so if I'm wanting to find the intersection of the diagonals, what am I looking for here? So essentially we know that one of our properties or theorems states that if a quadrilateral is a parallelogram, this implies that diagonals bisect each other. So we're looking for a midpoint. And when you're in the coordinate plane, we have formulas to help us find midpoint. So using the midpoint formula, we plug in all the numbers in the right places for the formula and discover that the midpoint of segment OM is located at 7/2, in other words 3.5, 2. And you could have chosen to find out the midpoint of LN instead of OM, because regardless of which segment you choose, in other words which diagonal you find the midpoint of, it should be the same point. So the coordinates of the intersection of the diagonals are at 7/2, 2, in other words 3.5, 2. You can check your answer by graphing and drawing the diagonals. The point of intersection appears to be correct. All right, so here on our final example 5, we have 3 vertices given for parallelogram WXYZ. So get those plotted, and what we want to do is find the 4th coordinate called vertex Y. So hopefully you're already thinking about this pattern, realizing that, first of all, it's a parallelogram, and by definition and our properties, we know that opposite sides are parallel. So if I think parallel, I should immediately think same slope. So that's immediately what I'm thinking about is my slopes. So if I'm looking at the given vertices, I can see WX is given, and then I'm trying to figure out where Y, so Y has to be somewhere over here if this is my shape to start my parallelogram. So I figure out my slope here, so it's up 5, left 2, and if that's the slope for XW, then that's the same slope I do to plot out and figure out where the missing vertex is. So your Y coordinate is located at 2, 1, And here are all the steps